All right, guys. Area of a triangle. You guys have been doing this, I think, since 8th grade, maybe 6th grade. I don't know. How long have you guys been doing area? How long have you guys been doing triangles? For a long time. If it's a right triangle, you guys know this one. So yeah, if we call this the base and that A and that C, the area of that triangle is 1/2 AB. But what if our triangle looks like this? I'm going to call that A. I'm going to call that B. I'm going to call that C. So this is still B. That's little a, and that's little c. It's still the same thing, really. We're going to call that height. The area of that triangle is still, yeah. The area of that triangle is still the same. 1/2 base times height. Yay or nay? All right, now do you guys see this triangle in, I don't know what color this is, aqua or something, or sky blue? I'm going to go ahead and use that angle A there, and I'm just going to say what sine of A is, because we're going to derive a formula that we're going to use forever now. So sine of A is H over C. So if I wanted to get H by itself, times C, H equals C sine A. And check it out, guys. I can replace that H here with this guy. And I have a new formula now. There's a formula we're going to use. 1/2 BC sine A. And there it is. That's not the only one. There's so many formulas we can use. It has to be side angle side. So what if I used this angle here, angle C? Well, if I use that one, I could say sine of C equals H over A times A times A, and I can get H equals A sine C. And then look, if I replace it in there again, I have area of triangle is 1/2. I'm going to put I'll put the B first. BA sine C, and usually you want to have it in alphabetical order, guys. So we're going to write area of this triangle is 1/2 AB sine C. So using context clues, give me one more formula using the angle sine B, or angle B. If I use sine B, what do you think I have here in the front? Well, look, guys, notice 1/2 BC sine A, 1/2 AB sine C. So if I use angle B, I have AC. These are my three formulas. Those are all how you get area of a triangle. Have you seen this before in geometry, guys, or no? Like this exact formula? Oh, man. Okay. All right. How do we use it? It's going to be simple. Oh, did everyone get it? Okay, sorry. Sorry, guys. Make sure your mode in your calculator is in what mode? Degree. Here we go. First example. In example 1, it says triangle ABC. Little a is 13. Little b is 15. Angle C is 71. Find the area of the triangle. I'm going to put NTS, not to scale. I'm going to draw a triangle. A, B, C. Little a is 13 inches, so there's my 13. Little b is 15 inches, so there's my 15. And angle C is 71 degrees. There is what you call in the biz or in geometry side angle side, SAS. Don't call it SAS. Side angle side. So this is what you need. You got everything you need for the area of this triangle, guys. It needs to be side angle side. When we do side angle side, we have the angle in between those two sides. That's what you need. So it's going to be 1/2 times 13 times 15 sine of 71 degrees. And that's it. You just type it in verbatim. Take your calculator. And here's my calculator. So let's see. Oh, let me clear all this ugly stuff here. 0.5 times 13 times 15. I think I got... Let me know if I make mistakes, guys, because my short-term memory sometimes is pretty bad. Sine 71. So sine, and I'm in radian mode, so let me go to degree mode real quick. Sorry, guys. Degree. There we go. And let me scroll all the way back to the right. Sine 71. Enter. Did everyone get that answer? Perfect. At least 3 digits after the decimal or thousandths place. 92.188. 92.188. Oh, don't say inches. No, it is inches, but it's area. So it's not just inches, it's square inches. Even though it's you see inches squared here, guys, you pronounce it square inches. Cool? You know why, right? Okay. No? Okay, then let's talk real quick. Look at the floor here. No, for real. Let's look at the floor. I have 1, 2, 3, 4. So I'm looking at these 4 tiles. Are you going to say those are 4 tile squares? So that's area. Or are you going to say those are 4 square tiles? Yeah, it's the shape of a square. So area is a dimensional of squares. So 4 square tiles. What about volumes? If you have cm is centimeters, and we have the third power, do you say centimeters cubed, or do you say cubic centimeters? Cubic centimeters. It's a box. It's a cube. So that's from geometry, guys. You guys know that. You guys are smart. There it is. So even though it says inches squared, you pronounce it square inches. And if you ever have a science professor or a science teacher say inches squared, go square inches. Don't be rowdy with them because they're. Anyways, let's continue. All right, look at this question, guys. Oh, we're about to do something super amazing. I hope that you guys love it. Find the area of triangle JDH. All right, guys, focus, Rodriguez. Little j is 5, little d is 7, little h is 11. Not to scale. And I'm going to just draw like so. Capital J, capital D, capital H. Little j is 5, so 5 centimeters. Little d is 7, so 7 centimeters. And little h is 11, so 11 centimeters. Notice it's a side. I do not have any angle. Can I calculate the area of this triangle at the moment with what we know? Man, I can't talk. No, we can't. Not yet. With what we know, I don't know. Maybe one of you knows Hero's formula. I need to figure out an angle. It does not matter which angle. Do you guys want to figure out little j or angle j? It's not little j. Angle j, angle d, angle h. What angle? It doesn't matter which one. Angle h? Okay. Let's figure out angle h. How do I figure out angle h? Is there a law that we recently learned on how to figure out that angle? Yeah, I heard someone say it. What does it say loud and proud? Law of cosines, guys. If I want to figure out angle h, put that 11 on the outside, 11 squared, equals, and then the 2 others, so 5 squared plus 7 squared minus 2 times 5 times 7 cosine of h. All I'm doing is figuring out what h is. Yay or nay? All right, what's 11 squared, guys? So 121 equals 5 squared is 25 plus 7 squared is 49 minus 2 times 5, that's 10. And then 10 times 7 is 70, cosine of h. Are we still okay? Has anyone gotten lost? Okay, now we're going to go ahead and add them up. 121 equals 49 plus 25, that is 74, minus 70 cosine h. Now let me know if I make mistakes, guys, because I make mistakes all the time. Are we still okay? Now I'm trying to solve for cosine h, so I'm going to subtract 74, So 121 minus 74, what's that? 74, 84, 94, 104, 114, what is it? 114, 24, yeah, I think you're right, 47. 47 equals negative 70 cosine h. Now, how do I get rid of that negative 70 there? Divided by negative 70, so here's what I have. Cosine h equals, I'm going to put the negative in the front, 47 over 70. And then finally, to get angle h, I got to do the what? The inverse. Negative 47 over 70. If we didn't make any mistakes, like here's how I'm going to type it in the calculator. Check it out. Because I want to use the exact one because I'm going to use Hero's formula in a little bit. I'm going to go second arc cosine, negative 47 over 70. I'm going to push enter. And that angle, obviously my triangle is not to scale at all. I'm going to store it because I want perfect, guys. So I'm going to push store, and I'm going to use the letter H, alpha H. Are we okay so far, guys? Or no? All right, so there it is. My angle H is stored, 132.177. H is 132.177 degrees. All right, here's my answer. So, area of this triangle is equal to 1/2 times 5 times 7 sine of H, which is stored in my calculator. So there it is, 1/2 5 times 7 sine of H. I'm going to type that in. So 0.5 times 5 times 7 sine of alpha H, which is stored in my calculator. Enter. 12.968712. Yeah, that sounds right. 12.968 or 969 if you round it. 12.969. Area triangle. 12.969 square centimeters. All right. I'm really excited about the next question, guys. All right. I'm not a history buff, but I want to show you guys something amazing. There's this guy by the name of Hero of Alexandria. If you Google it, sometimes he's called Heron. It depends. Some historians mess up his name. I don't know what his real name is. But Hero of Alexandria. Look how long ago he lived. Look how long ago he lived. Look how he lived. Okay, whatever. He lived at 100 BC. That is, what year are we? 2023? 2,100 years ago, this guy created this formula. No calculator, no technology. I do not know how long he spent to create this formula. But he created this formula to find the area of any triangle given 3 sides. And we're about to type it into our calculator, and you're going to see it's going to be the exact digit per digit. So my challenge to you, not that I've created anything that people are going to know 100 years from now, but guys, see if you can create something that humankind will remember for the next 2,000 years, just like this dude, Hero of Alexandria. So check it out. It says Hero's formula. Area is equal to S minus A, S minus B, S minus C, the square root of all that, where S is the semi-perimeter, half the perimeter. And so example 3 says this. Find the area of the triangle JDH in example 2. So this one right here that we just did, using Hero's formula. Confirm that you get the same answer. So let's see. Let's see if we do. It says that S is equal to 1/2 A plus B plus C. So that means those are the little sides. 5 plus 7 plus 11. 5 plus 7 plus 11. 11 plus 5, 16, 16, 16, 17, 22, divided by 2, 10.5? 11.5? I don't know. 5, 7, 11. Let's see. 5 plus 7 plus 11 divided by 2, 23 divided by 2, 11.5. 11.5. So that's my S. So 11.5. Now this is telling me to do area, and it's telling me to do square root. So area equals square root 11.5, parenthesis, 11.5 minus 5, close, open. 11.5 minus 7, close, open. And I know we can find the difference of that, but I'm just going to leave it. 11.5 minus 11. So let's see how good this guy was. So here it is. Here's my formula that I want. So I'm going to delete these 2 lines so I can see them next to each other. So I want that number right there. Second square root, 11.5, parenthesis, 11.5 minus what? I already forgot. 5. And then 11.5 minus, was it 7? And then the last one was 11.5 minus 11, right? All right, guys, here's the moment of truth. Ready? Are you guys excited? I'm excited because I haven't done this. I want to see how good this guy is. Let's see. Look at that. OMG. He had no calculators. He had no technology. It's the same digit per digit, guys. You don't think that's amazing? He did this 2,100 years ago without a calculator. I think it's amazing. I really do. I'm always shocked when I come across things like this. So this is why I love going to coffee shops with a math book and just reading the little snippets of history. Just amazing, guys. Just amazing. Just amazing. 12.969 square centimeters. Amazing. All right. There it is. I hope you guys are impressed. Now I'm just going to practice some Delta questions. So these 3 examples are coming from Delta Math. That's what you're going to have today. So let's see. Let's see if we can figure it out. The area of a triangle is 12. So the area of the triangle is 12. 2 of the side lengths are 4 and 9.6, and the included angle is acute. Oh, that's cute. Find the measure of the included angle to the nearest tenth of a degree. Okay, not to scale. My triangles are never to scale. So they're telling me I have a 4 and I have a 9.6. And they want me to figure out this angle right there that's acute. And I know that the area is 12. So I already know my area of a triangle. It's 12 equals 1/2 times 4 times 9.6 sine of that angle. I'm going to put theta. All you're doing is solving for sine theta. So let's see. 1/2 of 4 is 2. 2 times 9.6. I mean, I guess we could do it, but we have a calculator here. So I'm going to go 0.5 times 4 times 9.6. 19.2. And then what am I going to do? So here's what I have. 12 equals 19.2 sine theta. What you're going to do is get the sine theta by itself. So you're going to divide by 19.2. So 12, I guess I can just do it right now. Here, let's just do it in one step. Divide by 19.2, divide by 19.2, and then I have sine theta equals that. So what I want to do is I want to get theta by itself. So theta equals arc sine of 12 over 19.2, which equals, and I'm going to get an acute angle because it always gives acute. So let's see, arc sine. And then what was it on top? 12 divided by 19.6? 19.2? Thank you. Enter. So there's my angle. 36 point, they want it to the nearest tenth, so 36. Did I say 36? 38.7. 38.7. To the nearest tenth of a degree. Yep, there it is. Cool or not cool? Okay. Let's look at example 5. So example 5 is a parallelogram. Relax, don't freak out. Do you guys remember what a parallelogram is? All right, a parallelogram looks like this. I tried to make these angles the same here. Where both of these angles, angle A and angle B, are supplementary. And then angle A and angle C are congruent, and angle B and angle D are congruent. I just put all those 4 just for reference. All right, let's see what this says. It says the area of a parallelogram is 13 and the length of its sides are 9.4 and 1.7. 9.4 and 1.7. Determine to the nearest tenth of a degree the measure of the acute angle of the parallelogram. Yeah, one's acute, one's obtuse. Okay. Do you see, I guess the easiest way, I don't want to just give you the formula, I want to derive the formula. Do you see 2 triangles? If I cut it down the middle like that, it doesn't matter. I can cut it down the middle the other way around. Okay, so that means this formula, area of a triangle, 1/2 AB sine C. When you since I have 2 of them, I can multiply this by 2. So the area of a parallelogram is going to be this. Area of the P stands for parallelogram is equal to AB sine C. Since I use the angle C, I guess I'll tell you where angle C is. Angle C is this acute one, the acute angle. All right, I'll stop. The parallelogram tells me the area is 13, so I'm going to put 13 equals 1.7 times 9.4 sine of C. I'm doing the same thing that I did earlier, guys. So 1.7 times 9.4, let me get my calculator out. 1.7 times 9.4. 15.98, almost 16. So 13 equals 15.98 sine C. And then to get sine C by itself, you just divide by 15.98. So I'm going to write right here. Angle C equals inverse sine of 13 divided by 15.98. That's going to give me an acute angle, guys. What did I say? Inverse sine and 13 divided by 15.98. 13 divided by 15.98. And I'm going to push enter. Oh, go to, what did I do? Oh, I didn't do that little division sign. Bam, right there. Enter. 54.444, blah, blah, blah. Okay, I'm going to store this, guys, because I'm going to show you guys something in a little bit. 54.441. That's this angle. What if I wanted angle D? Remember I told you guys that they both sum up to 180? So all I got to do, and I'm going to show you guys something super awesome. Well, check it out. 180 minus that. I'm going to put C, alpha C. And I'm going to store this to D, guys. Store alpha D. Because I want to show you guys something. So watch. 125.5. This is just extra. I want to show you guys that this is also 9.4 because that's property of a parallelogram. And that's also 1.7. It doesn't matter what angle you use. You will get the same area of 13. So check it out. So if I put 1.7 times 9.4 sine C, I'm going to get 13. If I use 1.7 times 9.4 sine D, I'm still going to get 13. Watch. 1.7. That was one of the sides, right? What was the other side? 9.4. And then look, I stored it perfectly, so it should be a perfect 13. Sine alpha C. Enter. 13. And look at this. I'm going to do the same thing, but I'm going to change that letter to a D, which is the other angle. And I bet you I'm going to get the same area. Alpha D. Enter. OMG, look at that, guys. You don't think this is awesome? How it doesn't, like, how everything just works beautiful? I think it's awesome, guys. Everything just works beautiful. All right, let's go to the next one. Last one. The area of a parallelogram is 21, and the lengths of its sides are 8.6 and 3.1. Determine to the nearest tenth of a degree the measure of the obtuse angle. This time they want the obtuse. Every time I do the inverse sine, I'm always going to get the acute. Always. So to get the obtuse, you got to subtract from 180. Are we clear? Just like we did a little while ago to check the areas work away. So here's my little parallelogram. I'm not drawing it to scale, guys. Not to scale. None of these are to scale. Here's my acute angle. I'm going to call that C, and I'm going to call that D. So the area is 21. One side is 8.6. That's 8.6. The other side is 3.1. So here we go. Area, parallelogram, is equal to 3.1 times 8.6 sine of C. It's always going to give me the acute. I don't want angle C. I want angle D. So here we go. I forgot. I should have put A and P. I should have put 21 there. So that's 21. Let's figure out what 3.1 times 8.6 is. So 3.1 times 8.6. And I get that number, 26.66. So I have 21 equals 26.66. Did I do that right? Yeah. What happened, guys? Sine C. Did I make a mistake? Okay. C equals inverse sine. Can I skip a few steps? 21 divided by 26.66. That's not the answer, though. That's not the answer, though. So let's see. Arc sine. I already forgot. What was it? 21 divided by 26.66. All right. Okay, whatever you get, what am I going to do? Subtract it from what? 180. So 180 minus that answer. Minus, and I can just scroll up here. I don't have to save it. So there it is. That's the answer they want. They set it to the nearest what? 10th. So 128 degrees. So I'm going to put D equals 128.0 degrees. There it is. How do we feel, guys? All right, we're done. So all you got to do is some deltas. It's all the same over and over again. And that's it, guys.